Liquid launches. What is a liquid launch? This is an interesting one. So, my company, who are based in the defence sector, we've had some involvement in this with some UK companies. A UK company called Black Arrow Industries, who are really good at what they do. Black Arrow Industries, nothing to do with the Black Arrow rocket. It's just a name that Paul Williams at Black Arrow decided to use, and it's a cracking name. They've been looking at this for some time in terms of being able to launch rockets from ships. Now, this makes a lot of sense if you think about it, especially for an island nation like the UK, where at the moment, with what's happening in politics, and we go back to politics, it's a big story at the moment, going back to politics, what's happening with potentially with Scotland in particular, with the Indy Ref 2 and the potential that Scotland could devolve within the next few years. This would leave the UK with almost no launch capability outside of Cornwall with Virgin Orbit. Because most of the launch sites at the moment are based up in Scotland. So this notion, and with Scotland, obviously, you've got quite a limited launch capability in that you can only really launch into polar and sun-synchronous orbits. Now, if you think about it, Cape Canaveral and Kourou and the major launch sites around the world all launch into what's called equatorial orbits, which is things like the International Space Station. Vast majority of satellites that are hovering above us, of the 4,500 that are above us, probably about 90% of them are in equatorial and kind of that launch from an equatorial orbit. Polar and sun-synchronous orbits are useful if you want to do Earth observation and monitoring, where basically the satellite goes over the poles, sometimes staying permanently in sunlight, sometimes not. This is where sun-synchronous versus polar orbits come in. And effectively, the Earth's rotation underneath allows them to sweep over different parts of the ground. Now, this is useful for defense, for spy satellites, for Earth observation, for agriculture, all sorts of different reasons. Now, with China's a gigantic landmass, but their launch capability, typically they have got multiple launch sites, obviously inside the desert regions in China and some of the other CNSA controlled launch sites. But what they're thinking now with like sea-based launches is that they could effectively produce more or give themselves more launch capability. Now, if China are to be believed, and they're looking at things like these large constellations, and we're going to be talking a bit more about that with the Inmarsat report later, this will give them the capability and the scope to really develop multiple launch sites, so they could be lifting off with a much higher cadence or frequency than they are doing right now. The reason why it makes sense, over 70% of the Earth is covered in water anyway, and with ship stabilization, ship stability, etc. right now, this is more and more viable. This technology is not new. I mean, since about late 1990s, sea-based launch has been a thing, typically with old decommissioned oil rigs, etc., and launch platforms of that ilk, but more recently with large barges. And in the past, China have used solid rocket boosters with the Long March series. Long March 11 was an SRB-based launch, which took off from the sea, and they have been doing this for some time. Now, a company called Orion Space, and I hope I've pronounced that correctly, plus the Chinese kind of launch technologies group, CALT, and Gravity Group, they've all kind of colluded to look at the possibility for liquid-fueled rocket launches. Now, some of the issues with this in terms of stability, if you imagine, if you're launching a missile from a ship, and that's obviously quite common, that's been going on for decades and decades now, it's of a fixed and kind of nominal size, even up to things like Polaris, for example, and submarine-based launch. And you could easily potentially launch something into orbit from a submarine or from a ship up to a certain size. But what they're looking at now is much larger launch vehicles. So if you can imagine the amount of heat from the exhaust, the down thrust, etc., and the stabilization that you need quite a large vessel. And we looked at this with conversion of dry bulk carriers and potentially old aircraft carriers, etc., etc. And the work my company did on the Queen Elizabeth class and the Prince of Wales class aircraft carriers, with making the whole deck surface, it was a real challenge with the F-35s, the vertical takeoff and landing, and the amount of heat from the exhaust on those. But this is an order of magnitude, significantly greater than that. So what they're looking at is something, potentially a vessel around about 160-ish meters long, but about 40 meters wide, of these kind of launch barges, being able to launch liquid-fueled rockets into orbit. Now, as I said, what this gives China is a capability that really nobody else is actively pursuing around the world, outside of, as I said, the UK, with this company called Black Arrow. And I know Paul has talked to various organizations all over the world in terms of the benefits of this to them. from the UK's perspective, if this were to become a thing, then the ability to have a ship that could leave from, say, Irish waters, from Dublin, from Cardiff, from any of the major ports, for example, around the UK, and then either sail northwards and wait until you've got good sea state, good stability, and launch into a polar sun synchronous orbit, or go southwards, like off the coast of Portugal, etc. Now, the advantage is that the range safety aspect of that, which is your launch trajectory safety, making sure that the area around where you're launching is clear, even if something catastrophically goes wrong. During your launch, if something were to blow up and you were strewing debris down, what you don't want with a launch anywhere, and this is why Cape Canaveral is really good, because it kind of launches directly over the Atlantic, and there isn't much in terms of air traffic or sea traffic in that area. They tend to clear the area and make sure it's okay. It's really, really handy. And this is why I think this is a very interesting and viable idea. And again, China, who are rumored also to be looking at an 800-meter high launch vehicle. I don't know if you know about that one, Terry. It's quite what they're looking at. You think Starship's big, this thing's just off the scale. China again seemed to be almost leading the way when it comes to space-based technology and launch capability and launch cadence. I don't know what your thoughts are on this, Terry, but I think this is. I mean, we've obviously been landing spacecraft. Ground-based space says, talk about the Dragon, for example. We've seen SpaceX landing on barges now for years, and really, really successfully. I mean, the pinpoint precision now, even with the cameras working, because in the past, and they're using Starlink, ironically, for the cameras, but launching and landing, I mean, that would be the ultimate goal, I would imagine, to be able to launch off a ship and then be able to land back in the sea. Therefore, you've got a much better range safety, a much better safety protection kind of thing, in terms of if you're bringing rockets back down to the ground. If something were to blow up on a pad, you take out the pad. If you take out a barge, it's not as big a deal. Thoughts, Terry? I don't know what your...
Yeah. The only thing is, if things go wrong on the barge, you've nowhere to run to. Yeah, apologies, first of all, for dropping out there. I don't know what happened, but my unmute button wouldn't work, so I couldn't unmute myself, so I had to drop right out and come in again. Yeah, the interesting thing is that China already launches the Long March rocket from sea, has that capability. And some of the rockets that they're going to be using will be modified Long March ones. But yeah, the point you're making about launching ab initio, you're talking about a different order of magnitude, because it is so much more mass. You have all that fuel on board, whereas when a rocket's coming down to land on the barge, it's basically almost out of fuel. So first of all, there's a lot less weight coming down, and secondly, if anything does go wrong, the explosion won't be nearly as big. But yeah, it's the way forward. I'm also thinking this possibly ties in with China's activities in the South China Sea around the Spratly Islands, where they want to take that over, and they're building new islands and so on, not at the equator, but a lot closer than where they are at the moment with their most southerly launch option. So yeah, either building a base somewhere there, or using that the ports that they're building there as facilities, relatively nearby facilities for a seaborne launch vehicle, which would go to the equator. As nearest makes no difference. You don't have to be actually at 0 degrees. Anywhere plus or minus 10 degrees of north and south is very nearly as good. Yeah, it seems to be the way forward. And as you say, while you might possibly have an accident involving some crew, fatalities or injuries, you're not going to be injuring a large number of civilian population.
We did a lot of research on this, and as I said, investigations, specifically talking to companies like Black Arrow, because obviously we do a lot of work my company do a lot of work in terms of ship design. And one of the things was almost to use a fully autonomous launch vessel. So the crew effectively evacuate the vessel to a support vessel, which is n miles away from the launch site, depending on obviously the size of the rocket. Because the other thing that you've got is, if you've got an explosion, you can create waves, you can create shock waves, you can create all sorts of things that would impact. So having a launch kind of LCC launch control center on a separate vessel way away from the main ship, and literally just having a minimal crew with a kind of vertical assembly rig that almost, in effect, if you imagine the rocket is down inside the barge and then literally gets hoisted up, that seems to be the most logical way to do this. And then to have a third support vessel, which you could also have like your investors or people who may be involved in the launch, like you do on normal, or even tourists,
Yep.
to see a launch, because you think about, the downside of UK launch at the moment, especially with Virgin Orbit, is all you're going to be watching from UK airport is a 747 takeoff. You're not going to see any fantastic rocket launches. You're literally going to see a plane take off with a rocket strapped underneath it. So it's going to be as dull as dishwater in terms of watching the launch from the ground, as it were, as opposed to going to somewhere like Baikonur or the Cape, or any of the major launch sites. So yeah, it's a really interesting one, and one I think we're going to follow with intent, I would say, over the coming years and months, just to see where they go with it. Because, as I said, China are doing some quite astonishing things. I mean, they're talking. We'll probably talk about this in a future show about potentially beating everybody to get into, getting people to Mars as well. So who knows?
Yep, that's who my money's on.
Well, it has been for some. It's that.
Yep.
It's we both have the same view, Terry. Where you watch what China are doing, and it's a Mercury, Gemini, Apollo trajectory. They're doing the small step. They're doing up and down, one person, right? Now up and down with two people. Now we're going to orbit. Now we'll do docking. Now we'll build a space station. They're doing it really nice and steadily and progressively, and with great success. It has to be said.
And they haven't lost the momentum that the Americans did in terms of going out of low Earth orbit.
No, absolutely.
I mean, they're progressing steadily along that path. Certainly, America's done great things with the ISS and so on, and interplanetary robotic craft. But in terms of manned spacecraft or human spaceflight, you have to say now, they really lost the momentum after Apollo 17. Nothing more to the moon for, 50 years roughly?
Yeah, I know. Well, just don't get me started on that. We know about